Welcome to another video with me, Varun, on Tech Tablet. In this video, we would be covering the second unit, part one of understanding the R programming, understanding the unit which is basics of R programming, right? And this is as per the AKNU University. In the last video, we have covered unit one, and probably in the last video, that is after unit 5, I'll be posting all the important questions related to each and every unit with answers that should be of great help to all of you. So now, without wasting time, let us get into understanding what we will cover today in the first place. So as you can see, there are a few things that we would be looking at. Of these, the first one would be introduction to R and R Studio. The second one would be to understand what is R and how do we go about installing it. We will be looking at this practically probably as we keep going ahead. Then in the next, we will be understanding what is an R interface. What do we mean by an interface? Interface is how the screen looks. What are the different parts of our studio? Now, what is the difference between R and R Studio? R is a language, right? While R Studio is a tool to work on that specific language, right? So we would be working on our studio interface first. Then we would be understanding what is the screen, how does R look like, what are the different parts of the screen. So if this is your first time that you're learning to R or that you're listening to R, then you don't have to worry. I've got you covered. In the next part, we would be looking at what are the different data types. We'll be understanding what is the difference between numeric, character, float. We'll be looking at all those variants. Then we will be seeing how to create a variable in R, what are operators, different operators in R, in which we'll be looking at arithmetic operators to be specific. We'll be looking at comparison and logical operators. One exercise that you will have to do is whatever code is being displayed on the screen, I would ask you to pause the screen and probably immediately try it out in your RStudio interface. That would give you a really quick understanding about how to use the tool and probably how to get more familiar with it. And by the end of the video, you should be able to understand your tool, at least at a basic level, though not in complete. So let me introduce you to the R and R Studio interface. So firstly, first things first, R Studio that we are talking about, this specific tool that we're talking about, it is free and open source. Now, what do we mean by open source? It means that you don't have to pay any amount, or you don't have to pay huge amounts to be able to use this tool, right? It is free, and also the best part is it has a very huge community that you can take help or support from. Also, as I covered yesterday, R is a tool that has been built for statisticians. So it is designed specifically for data analysis, which becomes a gift for a lot of the developer community. Now, on RStudio IDE, which is an integrated development environment, you would be able to write, you would be able to run, and you would be able to visualize all your data in one place. So thus, it does not go without saying that R is a powerful open source programming language, which is designed for statistical computing, as you can see here, right? And also for data analysis. And to do this, we have a tool which is RStudio. So RStudio is an IDE on which R is executed. Now, when was R created? R was created in the year 1993 and now is rated among one of the top languages in data science. Now let's talk a bit about the interface. Like what you're able to see on my screen is exactly how R looks like. So I'll just move this from the top to the bottom. So here we have 4 screens. The first one is the script. The second one is the console. The third one is the environment. And the fourth one is plots. However, when you open a real-time interface or when you open an interface on your laptop, you would be able to see more than just this. So talking about the script editor, this is just as it looks even on your RStudio real-time interface. right? You would be having nothing else in the script area. Now, this is the place where you save your code, and this is the code that you will be sending to anyone for project reviews, or if someone asks you for your R file, this is the one that goes, the one that's in the script. The second one is the console. This part we are talking about. This is the part where you would be able to see your output and run the code instantly. These are not saved. These are just stored in your, local access. However, when you want to save the code, you would be copying them and putting them in the script code, or you would be executing in the script separately. Then you have environment. In the environment tab, you would also be able to access the history of your codes. You would also be able to see, some help or notes that's available for you, that you can be using at your disposal. Okay. And then finally, you have the plots or files. In this tab, or in the fourth segment, you would be able to see plots, files. You would also be able to access your libraries. Okay. And I think you would also be able to access your help. Okay. Now, libraries and help are very important for any person who's working on R or R Studio, because obviously, libraries, or I think when you open R, you would not be seeing it as libraries, rather you would be seeing it as packages. So packages or libraries, I think both of them are the same thing. Now, whenever you want to download or install, you have multiple tabs on the plots tab, which I will be showing it to you when we go on to the practical part. But yeah, when you go on to the packages, you would be able to download any package. For example, you have much needed packages like dplyr, you have ggplot2, right? All these packages are very frequently and commonly used when we talk about the RStudio interface, right? Then you have also different data types in R. That is a very important topic. So the first one is numeric. Now, any number, it could be a decimal value, or it could be, non-decimal value. Firstly, all of these fall into numbers, right? We all know that. Like even 100 is a number, and 100.5 is also a number according to us. But according to the system, things change a bit. Now we're talking about floating values, that is values with decimals. Then it becomes numeric in format, right? However, if you are working, if the number is a whole number, like it has no decimals, then it is an integer, right? Do not forget to keep these differences in mind, because when you see the output, you want to be sure what your output is, right? Then you have character. Any value, it could also be alphanumeric. Like let us say I write in something like hello 123. Even this is considered a character only, right? Anything that is enclosed within double quotes is considered a character. Like it could be x, y is a character, right? Then you have logical values, which is true or false. Then you have complex values, wherein you add 3 plus 2i, or x plus y, x plus 3z, all these values, right? And then you have raw, that is the information which goes raw as possible. So you have the most frequently used is numeric. You would be coming across integer a lot. You would be coming across character a lot, logical a lot, complex probably less. Okay. And to identify any of these, like, let us say when you're working on the code and you want to identify what is the data type of the value, then you can use class or type of. We have these specific commands, and these commands, they ensure that you can check your data type when you're working on our language. So now we'll talk about what is a variable. Now, firstly, let us say I want to create a value of x is equal to 100. Now, how would I do it if x is not storing anything? So here, x becomes a variable. So variable is basically like a storage location. So here, as you can see, a variable is a named storage location that holds a value. In R, you assign values using the arrow operator. Okay, do not forget this. We use equal to in Python. We use arrow in R. And always remember this arrow should be pointing towards the variable, right? So here, if you can see, we have three variables that have been created. And the exercise that I want you to do is try changing the arrow. So here you can see X has been marked as 10, right? So X is 10. Now, you could probably try replacing the value or the arrow something like this and see. Do the same exercise for all the three values, and I'm sure you should be able to understand why this task becomes important for you. All right, you would be seeing an error. And when you get an error, try to understand what the error is rather than just ignoring it. Right now, going ahead, uh, now there are rules when you want to name a variable, right? Now, whenever you are creating a variable, right, it must start with an alphabet or a dot. It can contain letters, numbers, dots, and underscores, right? And it is also case sensitive. So here, if you can see, we have my var or my variable is not equal to my variable. So what do we mean by this? We can see or notice here that there is this capital V, and in the next one it's a small v. So is R case sensitive? Yes, it is. And also when you are creating a variable, you are not expected to use reserved words. All these words like, if, else, true, false, or all these kind of words that are reserved or that are called keywords cannot be used as the names of variables, right? And also, when you're creating a variable, do not create names which make no sense, like x, x1, x3, x10, or y1, 2, 3. These kind of variable names become very confusing for us to probably go back to later. Instead, you could, probably give decent names that are readable and that are also easy to understand rather than just giving them as x and y. Now, what are operators? I'm sure you all know that. Operators are basic mathematical values that help us either, compare, add, delete, check. So these are the kind of operations that we achieve using operators in R. And as rightly, said here, these are the building blocks of computation. Because without operators, I think a lot of coding community would go hollow instantly, right? Now, what are the different types of operators? So you have arithmetic operators in the first place, comparison operators in the second place, and logical operators finally. Now, arithmetic operators basically have all mathematical values, right? Like plus, minus, etc. Comparison operators, as the name itself suggests, let us say you want to compare values like is 4 greater than 6, or is this condition greater than that condition. In that case, we go to comparison operators. And finally, you have logical, which is or, and not. Okay, so you have, okay, I think the third is logical operators, and you have three logical operators as stated here. Now, again, when you see this screen, I would, require all of you to pause the video for a second and understand a real world example and try coding the same in your R studio. No matter, I mean, even if you feel it is copying, I think it is a part of learning. And then probably you can go ahead with the video. Now, here we are trying to understand what is an operator and how do operators actually work. And we are using all the three operators. We are trying to use the arithmetic operator, the comparison operator, and the logical operator all in single shot. So just one exercise should give you a very good understanding of all the types of operators. So what's happening here? Here I'm giving two input values. So both of these are input values that are going into the system. So I'm taking total marks as 500 and the marks obtained by the candidate is 432. So in the first step, I want to calculate what is the percentage. So in order to do that, marks obtained by total marks into 100 is the percentage. Please note that we're using brackets as and when needed. This is all very simple mathematics. However, because this is the first time that you are coming onto a coding platform or a coding interface, let us take it very slow, right? So here you have percentage. We are writing the formula in line number 1, and in line number 2, I'm saying print the percentage. And if you can see this percentage, what I've written here is the variable name that I've created at the top, right? And the output should be 86.4 because 432 divided by 500 into 100 is 86.4. Then we are comparing, is this guy passed or not? And I'm giving my logic here and I'm saying that any value which is greater than equal to 40 is passed. Okay. So now we are trying to compare. What are we comparing? The percentage. And what is the value of percentage here? 86.4. So the system would now check 86.4 and 40. And we know that 86.4 is a pass value. So you would be having an output as true, which means the student has passed the examination. And finally, you have logical, okay, wherein again you're trying to see if the percentage is a distinction percentage or not. And any value above 75 is considered distinction. So, yes, this student has also received a distinction in the values. So, yeah, this is how we work on simple operators. Unless you are not able to understand these basic operations using our language, again, let me keep this very clear. These are most basic in nature. And unless you don't learn how to work on the most basic operations, it would become very difficult for you to scale operations which are large. So the three operations that we spoke about, arithmetic, they calculate; comparison, they check values; and logical, they compare two conditions and again, basically they check. Okay. The next one is a small exercise on different data types. So here what we have done in the part one that you can see is we have, like written the input values, and then we are checking the class of each of these. Now, before you take these up, I would want you to take a moment, pause the video, open the code in your R platform and try coding them. All right. As you try coding them and you would be checking the classes, you would be understanding what it is that we've been talking about just a while back, right? Then this is your first program. I think if you have practiced really, then this would be your third program, right? Now, what are we doing here? We're just giving three input values just for the namesake, and we are checking the output, right? Output can be checked using basic print command. So that should not be a problem. So we are printing the input and the output, right? As you can see, every place wherever you use the print command, you would be having an output that would be printed. And wherever you use the hash, right, these are called comment lines. These are used for you to, probably write some description about the code that you've come up with, or probably a small note that you would like to leave for the person who is, handling your code. Then comment lines should do the job. So I'm hoping by the end of the unit, again, we've not yet completed the unit, but by the end of this video, you have understood what is R and how does it fit in data science. You have understood what are the different data types in R. Okay, please do not forget this. And if you have practiced this at least once with me, then I think you would have definitely understood these. You've understood what is an R Studio and how do we work on R Studio and what are the different screens that we have on R Studio interface. You have worked and you have practiced on using variables correctly. You have applied arithmetic comparison and logical operators on a very small program in R. You have understood R interface, like what are the four screens of R, and how do they work and what do they work. And then you finally tried a simple, very basic beginner level code on R. Right now, here there is one thing that I've written for all of you to read through. The best way to learn R is to do R. Okay, there's no reading, there's no lot of going through it. Again, I think this stands true for any programming language. If you want to learn a programming language, then I think the best part is to go and do it. Right. So with this, we have completed part one of unit two. Right. In the next video, we would be covering part 2.2. So if you can check your syllabus, there are, other, topics that we have not yet covered in your part 2 or in your unit 2. And in the next video, we would be focusing on covering the unit 2 in complete, and we would be closing your unit 2 in the next video, right? So the goal is not to put any video more than 20 to 25 minutes, so you can have a quick revision recap, and go ahead and give your exams. And as I said in the last, I would also be putting all the set of important questions with answers, and wherever needed, you could just pause and probably have a quick go through and go give your exams. So I think that should do the job for you. All right, if you have enjoyed watching the video, then do not forget to hit the subscribe button and probably the bell icon for regular notifications. This is me, Varun, signing off. Thank you all.